So what we have here is my helmet, but it is no ordinary helmet. This is a fan-cooled helmet. What does that mean? That means when I wear safety glasses with full seal even, it has a fan in it that helps prevent fogging. I am a very sweaty person, so you'll see in the following video just how fogged up I can get. To show you exactly how bad my fogging issue is, I'm going to run around my yard and get myself all sweaty. So give me a minute here. Alright, now I got some fog on there. I don't know if you can see, it's kind of cold out, so it's clearing pretty quick, but when I turn the fan on, it goes away even faster. Look at that. No more fog. This is a godsend when it comes to days like rain and low humid days, like low temperature humid days. These things are amazing. So this is a pretty simple design. What we have is first and foremost a 40 millimeter computer fan up in the front. That's the powerhouse of the whole thing. Above and below the computer fan are two 3D printed parts. I have the top part, which is a BB shield, so that way BBs from the airsoft games won't get into the fan and screw it all up. And I have the mounting piece that allows me to put the fan on top of the helmet. You'll see I've run the wiring through some patches just for some organization. And right here I have the switch. Turning the switch on, turns on the fan. Off, turns the fan off. It is connected through a Dean's connector to a battery that I've mounted in the back of the helmet in a pistol pouch. This particular battery is an 11.1 LiPo. However, you can also use a 7.4, it just means the fan is a little bit less powerful. I personally prefer the 7.4s because the fan's quieter. And you can see on the inside, I've made the ductwork out of EVA foam so that way it doesn't put any hard surface against my head, and it's piped out through the front there, and that's where it gets into the lenses. And finally, there's another piece of EVA foam on the tip here that directs the air inwards towards my face. So far, this is the best anti-fogging solution I have ever used, even compared with the fan goggles. I've had issues with the fan goggles where they just don't have enough space between the helmet and the goggles themselves to vent enough air. So today, I'm going to show you exactly how you can make one of these fan-powered helmets for yourself. Here are all the materials you're going to need in order to make this fan helmet. The first thing you're going to need, starting at the top, is the helmet. This is a replica FAST helmet manufactured for airsoft purposes. It is not ballistic, it is just a regular ABS helmet. Next are the adhesives. This is the silicone. This is Dynaflex 230. It's a window, door, and trim sealant. I use silicone because it can usually be used as an adhesive and is also paintable. It is the white stuff, so that way it can be painted over. This time, I'm going to try using the 5-minute epoxy as well as the silicone. So get yourself a good 2-part epoxy. You're also going to need solder, preferably with flux included. You're going to need a length of shock cord. You can pick shock cord up probably on Amazon. I got mine from Mil-Spec Monkey Store. You should probably go with the thicker stuff. I believe this is 1/8 of an inch thick. Shock cord is basically a bungee cord, and I use it to help maintain the battery holster, which I'll get into later. Then you're going to need a switch. I'll link the specific switch because it works with my 3D printed parts. This is just a simple 3-pole switch, but it's only got 2 positions. It's supposed to be left and right. However, I basically didn't wire one up to one of the poles, so it's just on and off. You'll also notice this is a printed piece of paper and not an actual switch because I just so happen to misplace all my switches and I'll have to find them soon. You're going to need a connector. You don't have to use a Dean's connector, but I just so happen to have a bunch of Dean's connectors lying around. They're also known as T connectors. These connectors I'm going to use to connect between the battery and the switch. Next, I have Velcro. You're going to need some length of double-sided Velcro, which is the Velcro that has both the hook on one side and the loop on the other side. And you're also going to need some hook Velcro with a sticky back. The sticky back hook Velcro is for the switch assembly. You're going to need wire and the appropriate heat shrink for said wire. I'm using 18 gauge, which is Perfectly fine for this particular. You can probably even go lower. You can probably go to 20 gauge wire. You're going to need some sort of battery holster. For this, I'm using a pistol mag pouch made by Condor. You can pick up any kind of pouch that you think will do the job. You're going to need a battery. I picked this particular battery up from Hobby King. They have a wonderful assortment of airsoft batteries. Just keep in mind the type of connector that is used on it. Notice how this one already has a Dean's connector installed. Some of them don't have the Dean's connector. Some of them come with a Tamiya connector, which is a different connector altogether. So keep that in mind when you're figuring out what you're going to connect between your battery and your switch and your fan. The first 3D printed part is the BB shield. This is the top part of the fan. The second part is the mount, which allows me to connect the fan to the helmet. And the next part is the switch assembly. We have the switch baseboard, we have the switch top piece, and we have the actual switch itself. These all connect with the switch. With this switch, and we will solder everything to the board when we get there. You're going to have to pick up a 40 millimeter computer fan, 12 volts. You're also going to need to pick up 4 3 millimeter wide by 20 millimeter long socket bolts with the nuts that you need. These ones are the hex nuts. The hex nuts will be the only ones that fit into my particular 3D printed baseboard there. I almost forgot, what you're also going to need is some EVA foam. You can pick this up on Amazon. It's basically just a very light foam that's very strong. And to adhere said foam to itself or other things, you're probably going to want to grab some contact cement. However, in a pinch, you can probably get either hot glue or the epoxy to work with it as well. It's just a lot easier to work with EVA foam with contact cement. For tools, what you're going to need is your wire soldering equipment and wire cutting equipment. To cut out the hole in the helmet, you can either use a drill with a 1 3/8 inch Forstner bit or a 1 3/8 inch spade bit, or you can use a Dremel. You're still going to need the Dremel anyway to soften up some edges on the base plate for the fan, but you can also use it to cut out the hole with the accompanying cutting bit, not shown here. You're also going to need some general marking equipment. Now that we have all of our parts and pieces together, it's time to get to work. Now, unfortunately, I had gotten ahead of myself and started cutting out the helmet before I had the camera equipment going, but I am going to go over with you exactly what I did. What I used was a drill because it was easier for me to cut out the hole. What you're going to do is you're going to take your Forstner bit or your spade bit and get it ready like so. Take your base plate and mount it on your helmet with the thicker part facing the front. Find out exactly where center is. I eyeballed it, and as close to the night vision optic mounting equipment as you possibly can get. I had to cut out some of the Velcro on mine in order to get mine to fit in properly. Then, take your marking equipment and mark the circle. After the circle is marked, take your drill bit, get as close to the center as possible, and drill your hole. If you're using a Dremel, just put the cutting bit in, make your first hole, and then follow the line as best as you can. Then put on the sanding bit, come back, and clean up the hole. Now, when I designed the base plate for the fan, I only put one curve in it, and that's the curve you see there. Unfortunately, that doesn't contour to the helmet very well. So we're going to take our helmet, and we're going to put it on there and figure out exactly what needs to come off. Now, this is more of an eyeball procedure. Just see where it's touching the helmet and where it's not touching, and then make a decision about where you want to take some material off. I've already started the process, but it still needs to have a little bit taken off, so we're going to do that now. For this, you can use a Dremel with the sanding bit attached. Remember, when you're using power tools, always use the proper safety equipment. You're probably going to have to take this back and forth a few times until you get it just right. Once you get it approximately where you want it, take your helmet and the piece and mark out exactly where the piece sits. Now that we have our mark there, we're going to take our Dremel once again and put it on the low setting, and we're going to scuff up this surface so that way it gives the glue something to contact to. Now that we've got that all scuffed up, we want to remove as much of the dust as possible. So I have an air hose. What you guys might want to consider doing if you don't have a high pressure air system is to use a faucet and wash it and dry it real well. I'll be right back. This next step is very important because if you don't do it, you're going to screw yourself up in the long run. Collect all the nuts that you need to finish the assembly, all the hex nuts. And you're going to insert them into the 4 slots on the back of the base panel. They should fit fairly snug. For the deeper holes, you may need to use one of the bolts to push it in there. Thread it just a little bit and then push it all the way in. I like to test thread from the opposite side just to make sure they're in the right spots. All right, now we have the base plate and the helmet prepared. The next step we're going to take is we're going to apply the epoxy, or if you chose, you're going to apply the silicone. I'm going to go over the silicone first in case this is your first time using it. When you use the silicone, you're going to want to be very liberal with it. Make sure your stuff is good and it's not dried out. And if you're using old stuff. And then I'm just going to do this as an example, as a mock, so I'm not going to actually apply it. Apply a nice fair bead to the scuffed up surface on the helmet, and then apply another bead onto your other piece. Then once you stick it on, make sure pieces don't fall out. Well, poop. We're going to pretend that didn't happen. Once you stick it on, you're going to want to make sure it stays in place. Use a piece of tape, such as masking tape, scotch tape, painter's tape, anything, or maybe even a large rubber band to hold it in place while it dries. You don't want to apply too much pressure because you need some of the thickness of the silicone to remain there in order to keep it in place. Then, after it's all in place, take a paper towel, wipe off the excess from the inside, and then take your finger and then rub it along the edge in order to remove the excess from the outside, and rub your finger on the paper towel to get rid of it. That'll give you a nice clean bead around the outside. For this, however, we're not using the silicone this time. We're using the two-part epoxy, which I highly recommend because of its strength. What you're going to need for the epoxy is a piece of tin foil to mix it on. You're going to need an acid brush or another type of small brush that you don't mind sacrificing. And I like to use a popsicle stick, but any kind of mixing instrument will do. A lot of two-part epoxies come in a unit that's designed to dispense equal parts at the same time. I, however, have 2 bottles. So I'm going to put as equal amount as I can onto my mixing surface. Then mix it up. Now remember, you only have 5 minutes to work with the 5-minute epoxy, so you're going to actually have to be a little bit quick with this, but also be careful because you don't want to ruin your work. After you got it all mixed up, you're going to want to apply it to both surfaces. You want to be careful not to add too much around the bolts. You want to be careful not to add too much around the nuts because you don't want it to ease into that hole and cause problems. I don't think I have enough, so I'm going to use what I have instead of making another batch. Now we apply. Use plenty of force and hold it in place. You're going to be here for a little while. After you've held it for about a minute, it should be able to hold itself on by its own tack. Leave it alone. I know it says 5-minute epoxy, but give it a good half an hour before you work with it again. So we're going to set that aside. Alright, our glue is set. I have tested the bolts to make sure they still fit in the nuts there. So that way we don't have an issue where there's too much glue in there, and they seem to be okay, except for this one corner, which I might have to flush out a few times, but it's not the end of the world. So next thing we're going to do is we're going to take our silicone, and we are going to apply it all the way around to give a nice bead. And what that'll do is help seal it and keep the airflow sealed, and also give it a more smooth look. So have a paper towel ready because you're going to need it. Open up your silicone. Get rid of a small bead here as it's the stuff that was in the tip. Not great. All right, let's do it. All right, now our silicone is in place. Silicone takes a while to dry, so you have to be careful with your project. I recommend not touching it for at least a day, and definitely not painting for that amount of time either. If you just siliconed, you're going to have to wait a whole day before you touch your project again. However, if you have used the epoxy and let it set, you should be okay to attach your fan and also attach the upper shroud that goes with it. Keep in mind exactly where you want the wires to come out of your fan assembly once you put this together. In order to screw in your fan, you're going to need a 2.5 millimeter socket or an Allen key. What you may need to do is pre-screw in these bolts in order to pull the nut a little bit closer to the surface before you attach the BB shield. Now this process I've already completed because I was using this particular pouch on my last setup, and I ordered a green one because it's going to be my green helmet setup. But what you're going to want to do is take your double-sided Velcro and cut off a length long enough to go in between the molly webbing of your chosen pouch to give it, and make sure it's hook side out, and that will give it a way to attach to the helmet initially. Now what you may notice here is that I don't have any Velcro on that particular part of my helmet, so I'm going to have to get some sticky adhesive Velcro in order to fix that. In order to place the sticky loop side Velcro where I want it to go, I'm going to attach it to the Velcro on this side first. And then first line it up, and make sure there's no dust on your helmet or else it could interfere with the adhesive. Once you have it mostly adhered, carefully remove the pouch and then give it another good stick. Now's the time where you want to get your shock cord, and there were two tools I forgot to mention, but you should have some lying around your house. The first thing is you need a lighter or another source of flame, and you need a pair of scissors. Take your shock cord length and run it through the molly loops on your pouch. Now you're going to want to find a way to get this loop through the helmet. I'm going to end up drilling new holes. If you have a Dremel with a cutting bit on it, you can use that as well. Now take a good look at where you want to place these holes, because they might not be as far away as you might think. And also make sure you're not going to obstruct anything when you drill through the other side. Stick the shock cord through the hole. Now you're going to want to tie a knot on the inside. Make sure to leave as little as possible, as this is the inside and you don't want it to be hitting your head. So get a nice tight knot in there. There. Place your pouch exactly where you want it. Feed the rest of your shock cord through the other side. Now tie your second knot. Again, make sure this gets really close, so that way you have the elasticity of the shock cord holding your pouch to the helmet. You may need to give it a little bit of help from the other side. Once you have your shock cord pulled through, take your scissors and cut it off. Now carefully, using the lighter, fuse the end of the shock cord on the inside of the helmet. Now we're going to clean up the switch components. If you needed to use a brim when you printed, now's the time to cut off the brim. Alright, I have my switch. These are tiny little buggers, by the way. Now that we've got our switch assembly, I'm just going to test fit to make sure the top of my switch works. Which it does not. I have to clean it out a little bit. Now that we have all this stuff cleaned up, we're ready to work on our switch here. So we're going to take our switch and place it inside of our switch base. What I'm going to do is I'm going to use the switch top to push it in place. There, and do a quick test. It works. Now, the next step is you need to carefully solder onto the switch plate. Between there's a wall in here that's going to prevent arcing. So what we're going to do is we're going to solder to both of the wires. So the center wire and the side and the other side of that wall are going to get soldered on, and those are going to be our negative. So it's time to get the helmet back. With our solder warming up, of course. We're going to work on this. This is going to feel wrong, but you're going to have to cut off this connector from your fan. With a utility knife, you can cut that heat shroud as well. There. Now we've got some wire exposed. We're going to strip that wire. This is going to be kind of hard to show you on camera because everything needs to happen close to me. Let me get a block. Now I'm going to bend these terminals ever so slightly. Just to help me out. If you have a set of helping hands, now is the time to use them. Make sure to go to the center terminal. Now I'm not going to attach this for good. I'm just going to do it for testing purposes. So I'm not going to use any glue, and I'm only going to put it on here lightly to protect our connections. Next, we're going to work on the red wire, the positive. Don't forget to put your heat shrink tubing over the new connection you just made. We're going to do that in just a second after we figure out where to cut the wire. So the next thing you want to do is figure out exactly where the wire needs to be cut. So our switch is going to go right here. So we need to make sure we have a fair bit of wire to get to the connection. We don't need to worry about the yellow wire. Right about there seems good. You can use a heat gun, or in a pinch, you can also use a lighter to constrict the heat tubing. Now we're at the point where we're ready for our Dean's connector. This is going to be the male end. If you have a Dean's cap, make sure to insert it onto the wires before you begin the soldering process. Also make sure your heat shrink is properly placed as well. Make sure you're lining up the proper ends on your Dean's connector with the right wire. First, you're going to want to put a glob of solder onto your Dean's connector. Not too much. Then you're going to want to put some solder on your wire. Make sure your wire end is sort of flat. This makes a better adherence to the Dean's connector when the solder has dried. Repeat the process on the other part of the Dean's connector. Test to make sure that your adherences are good by tugging with a little bit of pressure to make sure nothing pulls off. Once you're all set, move your heat shrink up to the right point, being careful not to burn yourself. And use some heat to heat that shrink. Now, if applicable, move your Dean's cap so that way it caps off those ends. Now we're ready to test our fan. The moment of truth, everybody. We're going to start with our switch off. which is towards the battery. The fan should not start when I plug it in. Awesome. Now we're going to start our fan up. We have power. We did make a minor mistake. We installed the fan upside down, so it's blowing out. We want to switch the fan's direction. You can cut off excess yellow cable. That's just the sensor. We don't need to install a sensor. We're now ready to glue our switch assembly together. Take it apart once more. You're going to want to grab your silicone. That'll give us a nice watertight seal while also being non-conductive. And put a small bead around the inside. And be very liberal around the wire areas to make sure they seal properly. Make sure to install the switch housing in the same direction that you disassembled it. Wipe off any excess silicone with a paper towel. Now it's time to put the Velcro on the back side of the switch. Make sure the back side of the switch is nice and clean. I like to use patches to keep my wires nice and organized. We are almost done. The next and final step is to do all the duct work inside of the helmet. Most helmet liners will come off the same way. They slide towards the inside. With the helmet liner removed, carefully plan how you want to run your ductwork. And using your utility knife, cut it out. Carefully plan where to put the EVA foam in order to create the ductwork that's going to channel the air to the side of your goggles. Carefully apply a layer of contact cement to both surfaces that you want to adhere. When it comes to contact cement, remember, less is more. Give the contact cement enough time to tack up. The next thing you're going to do is you're going to cut out the piece that's going to direct the air from the inside of the helmet to the inside of your goggles or glasses. What we're going to do is we're going to cut this piece at an angle so that way it gives the channel direction. Then we're going to do the same thing we did with the contact cement from the last project. Applying contact cement very conservatively to both surfaces. Don't forget about the cap that's going to keep the air in the channel. We're going to cut that out of the EVA foam next. Very carefully press the two contact cemented surfaces together, being very careful about how you put them together. Now we're going to put the last and final piece in. This is the piece that's going to keep everything together. Now we're going to apply the final bit of contact cement. You can reattach the front cushion by doing the opposite procedure of how you uninstalled it. Putting it into the slot and then pushing out from the center. Now that our contact cement has tacked up, we're ready to install this next piece. Alright, time for a test fit to make sure the ventilation pieces that I installed inside aren't going to get in the way of the actual helmet performance. Seems clear. Alright, so the helmet fits. I can strap it in. Doesn't feel too heavy. Now, the piece de resistance. We're going to test the fan one last time. Plugged in. Turned on. Our fan is moving. And our fan is cooling. If you liked this video on the detailed instructions on how to create a fan helmet, please leave a like. Also, let me know what you think about it in the comments down below. And thank you for watching, and I hope to see you all again real soon. Goodbye now.